Okay, let's begin. So this is Stat 992, Computational Statistics. For those of you by chance who may not know me, my name is Chris Biller, Professor in the Department of Statistics. Let's begin by taking a look at the syllabus. The way that I simply pass things out is I'll give half the papers to the first person in the first row on this side and do the same thing on this side of the room. So while that's going around, let me tell you a little bit about myself. I am a native Nebraskan. I grew up in the Millard area of Omaha. In fact, I went to Millard South High School, and my dad still lives right nearby. I got my undergraduate degree in mathematics from UNO. Then I went to K-State for my master's and PhD in statistics. After that, I was an assistant professor at Oklahoma State University for 3 years in their Department of Statistics. And then about late 2002, early 2003, I found out that Nebraska was finally starting a Department of Statistics. So I thought that would be a great opportunity to come back home and also to get season football tickets. It's worked well for me coming back home, except for the football part. Let's hope the new coach is successful. Anyway.
You've had tickets though, right?
Oh yeah, I still have tickets, but I only go to.
Outcome.
What's that? Yeah, that was a good outcome, but it's just not the same as it was the previous 40 years. In fact, I usually sell about half my tickets each year now. Also, it's just horribly expensive, and that's why I do it. I still sometimes think I'm a poor graduate student and live that way. Anyway. Okay, so let's talk about the syllabus. Let me bring that up. Okay, so computational statistics. Let me give you a little bit of background of the history of computational statistics courses in the Department of Statistics. Back when I started graduate school in 1994, these courses existed, maybe about in half the Department of Statistics, maybe 3/4. It was an elective course for PhD students, and maybe offered once every 2 years. The course primarily was focused on how to simulate data from a probability distribution. So, you know, you've all seen the R norm function in R, and that's an easy way to simulate data from a normal. But you know, what are the actual algorithms that are used in that function to actually do the process? You know, how can we try to get a random sample? I mean, those functions don't actually, or that function doesn't actually give you a random sample, even though we treat it that way. But what's the process used to try to emulate a random sample? And you would typically spend most of your time in a computational statistics course doing stuff like that, using C and Fortran for everything. I did not take a computational statistics course when I was a student because I didn't think that was really fun. Things have changed, obviously, over 20 years, and these computational statistics courses have evolved. Now, in most departments of statistics, some kind of computational statistics aspect, whether if it's in a course called this, or if it's in another course that has this as a strong component, they're typically required for all PhD students in departments of statistics nowadays. And the reason why, there's 3 main reasons why. There's other smaller ones, but I'm going to focus on 3. First of all, Bayesian statistics, Bayesian methodology has just, you know, really grown. While Bayesian methodology has existed for many, many years, even before I started grad school, it wasn't until the 90s where we actually had the computing power to implement these kinds of things rather simply. All of you should have at least a little bit of Bayesian stuff from your Stat 883 course, and you know about things called posterior distributions. Well, typically in the past, you know, if you want to do something Bayesian, you need a posterior distribution, and you had to actually derive the you had to be able to actually derive the actual distribution in order to do stuff. Now, instead, what we typically do, especially for a lot more complicated problems, we can simply simulate a distribution. using methods like Markov chain Monte Carlo stuff. And so that really opened up the doors starting in the 1990s to a whole lot of research that went on then and even still continues today. Now, this is not a Bayesian class here. We will talk about like MCMC, Markov chain Monte Carlo methods in this course, but this is not necessarily a Bayesian course, so don't worry if your Bayesian background coming into this is not much. Now, another thing that happened that made these computational statistics courses of interest is the thing called the bootstrap. You probably have all at least heard of the name. You might not necessarily know exactly what it is, but when it was first came about in 1979 with a paper by Bradley Efron, still teaching at Stanford, one of the most famous statisticians out there. I should back up. There was bootstrap stuff, some ideas that were out there before he actually came up with these landmark papers in the late 1970s, but it was him who actually kind of put it all together. Well, this bootstrap relied heavily on the use of computers to simulate probability distributions. Obviously, back in the late 1970s and 1980s, that was maybe we didn't necessarily have the computing power to really implement it as much as we want to. Well, in the 90s, we started getting that computing power. And now it's actually very common nowadays for a statistician just to use the bootstrap in any kind of data analysis. The third main thing that happened was the advent of R. R has really changed things. Now, you've had me in the course before, you know how I preach about R, but it truly has. You know, in the 20 years I've been in the Department of Statistics, either as a student or as a professor, I've seen the birth, and I've seen how the transition has gone from using a software package like SAS to now R being the dominant software packages in the Department of Statistics nowadays. That's not necessarily the case here, and I'm not necessarily saying that is anything bad, but if you look at other departments of statistics, it's R that's the number one. And the reason is when it well, there's a number of reasons why R has really changed things. First of all, it's free, obviously. But second, and this is very important, it gives a way to disseminate one's research through packages, or even just writing a function itself and putting it on your website. Anybody can download R since it's free. They can run your function in R itself. It's the dissemination thing that's really that really drove R being so popular. You know, the most current research is programmed in R. Just take a look at JASM. Take a look at biometrics. Take a look at any other of the big journals. People are doing it in R. Or if they're maybe doing it maybe a little bit in C or maybe some other software package, or programming language, I should say, they're allowing you to be able to link, let's say, a C program to R. And so those three things, and then there are, again, some other things too, but those are the three main things that has really led computational statistics courses to be very popular. When we had an academic program review back in fall 2013, we had a professor from Purdue, Iowa, and Ohio State come here. And one of the main things that they said was, your department doesn't have as much of a computational statistics background as it should. Your students are not getting it. And so thus, that is why then I propose to teach this course. Okay? So that gives you a little bit of the background behind this. I think it's important for you to know. So that's why I decided to talk about it. Also, I'll say, we won't do anything in C or Fortran like you would have 20 years ago. We might touch on a few other languages, but primarily this is going to be very R heavy based. Okay. Also, I'll say that this is the first time I've taught a computational statistics course before. I've taught about 3/4 of this stuff in the past in my Tools for Statisticians course or in my Bootstrap course, Stat 950. And the remaining material I've used it, let's say, heavily in my research. For example, like the E logarithm. I haven't taught it before. I've used it heavily in my research. So I don't have all my lecture notes done yet. They will be. This course will be an evolving process here. You know, if you've taken a course from me before, you've seen everything nicely laid out. We know what we're going to do in 2 weeks from now. That might not necessarily be exactly the case. I have general ideas of what we're going to do, at least for, I would say, about 2/3 of the course right now. But the other third, we'll just see how it goes. And you're going to see some reflections of seeing how that goes as we go along here today, especially reflecting the syllabus. Okay, so my name again is Chris Biller. Please call me Chris. Don't call me Dr. Biller. My office, just in case you're not familiar with it, here's a nice little map of East Campus here. To orient you, we have Holdridge Street down here. We have 33rd Street coming up along here. Hardin Hall, my office is in the northeast corner of the 3rd floor of Hardin Hall. Move that down. I will be having office hours Tuesdays and Thursdays from 4 to 5 p.m., of course by appointment as well. My other course that I teach, Stat 875, is at 2:30 on Tuesdays and Thursdays as well. And I will need most of the time between this course and my categorical course to prepare for categorical. So if you have a question after class, feel free to ask it, but let's try to keep it brief. Okay, because it usually takes me about an hour and a half, 2 hours to fully prepare for a lecture before a course or before a class. My web portal to all my materials online is chrisbiller.com, and you'll be able to access then the Stat 992 or Stat 992 website through chrisbiller.com. Just simply, if you haven't already done that already, let's show up here. So chrisbiller.com is simply a forwarding web page to the actual physical website up there, statistics.uni.edu/faculty/builder, and here's Stat 992. I will rarely use Blackboard this semester. There will be mainly 2 things that we will use it for, and you'll see at least one of those things as we go along here today. Okay, so the book for the course. I had a difficult time deciding on a book. Part of the reason is that typically with other computational statistics courses taught in the Department of Statistics, I shouldn't say typically, but often, one particular book is not used. You know, since the actual format for a computational statistics course typically varies from one institution to another, unlike established courses like a categorical or a multivariate course. Since there's a lot of that variability, there's not necessarily one good book that covers everything. So what I did during the joint statistical meetings back in August, I visited all the publishers that were exhibiting their books there, and I was looking at their computational statistics books. And I found 3 books that I wanted to examine further. This Bloomfield one, this Givens and Houghton book, and also the Jones et al. Book. So what I did was I requested from the publishers some more information about their books in the fall, and I had some sample copies of the books. And as a way to make a decision about which to use, I decided to write up the lecture notes for 2 sections of this course. And the book that ended up being I felt was the best, that's the one I would choose. And it ended up being this one, Bloomfield. And this is not a traditional book that's used in computational statistics courses, but at least for the sections I was writing lecture notes on, and through looking at some other stuff in it, I thought it was good. I liked how they explained the stuff that I was writing the lecture notes on. However, please note that we will only be using this Bloomfield book probably for about 4 weeks in the course. There's other good stuff in here. I don't want to persuade you not to buy it. But we will only use it for about 4 weeks. Okay? If you really, the book's not that expensive, but if you really, really want to save money, maybe a couple students get together and share a book, for example. I wanted to do it that route. Now, this Jones book, they have some good stuff in it too, but I quickly eliminated it because I thought sometimes it was really too basic, and other times like, well, why didn't I was disappointed they didn't include something. Now, of computational statistics courses that use books, this one and this one, which happen to have the same name, are typically used the most. Gentle itself, and I felt some of the stuff was kind of dated in it, so that's why I didn't use it. But it was a tough decision between the Bloomfield and the Givens books. It was a very tough decision. So this is what the Givens book looks like. This has more of the topics that we're going to talk about in this book than this one does. But I was kind of disappointed in how they explained some stuff. And also I thought, and this is the second edition. The first edition was written in 2005. I thought some of the stuff that they were explaining maybe wasn't as needed as it was maybe in 2005. And so that, and the fact that you could get the book for free from our library is what made me say, okay, let's use this one. So this, if you looked, hopefully you have, at the bookstore, you'll see that this is a recommended book. I still recommend it. So about a week ago, I started finalizing my syllabus here. And I was clicking on links just to make sure the links all worked. And let's see what happens when I click on this link here.
That's what I got.
Yeah. So, since I made this decision in October, between October and now, for some reason now the book is no longer available for free. If I had to go back to do it again, that might have been enough to persuade me to use this book.
That one's actually a lot cheaper than the first one that you held up too. So if people
This one's a
want-
lot cheaper?
Yeah, you
Really?
can get that for like $50 on Amazon.
Okay.
And the other one, actually the ebook is cheapest. If you get it on Amazon, not through the bookstore, it's like $20 cheaper than through the UNL
Okay.
bookstore. But
Well, let me say a few things, and if there's any other comments, please speak up. The cheapest place to buy CRC books, I know this for a fact because I am an author of a CRC book, is their website. Okay, go to their website. That's the cheapest place to buy the book. Also, go to like a place like retailmenot.com, and you can find discounts there that might even lower this price more. Okay. Do not. I strongly recommend not ever buying an electronic version of a CRC Press book. As many of you know, I just published my own book that was through CRC Press. The electronic version for my book, I first saw it in September, is not good. There are errors in it. Not errors that I put, but errors from them transferring it. I don't know why they did this. Essentially, I think they probably retyped my whole book. Even though I did everything in LaTeX. They retyped my whole book, and they got some of the notation wrong, some other little things wrong. Also, the electronic format, just from looking at it in a web browser, is not good. You know, sometimes you'll have, let's say, some computer code that's like in a size 12 font. Other times it'll be in a size 20 font. So I won't get into this too much, but I actually contacted my editor and say, hey, this doesn't look good. Can we fix it? And the key thing is that it's not the CRC who's doing it. It's actually they're farming out or sourcing out the electronic version to another company, and they're doing it. They said that they'll try to fix it, but that was at least 2 months ago, maybe 3 months ago, and nothing's happened. It's kind of disappointing, at least for me. Nowadays, I'd rather have the electronic version. I'd rather have, just give me a PDF, give me an electronic version of the book, I'm fine with that. It's a lot easier to carry around an electronic version than it is this version. But you know, they still don't have PDF versions of their books that are available for some reason. It's all web-based through this company. Hey, was there any other? Yes.
I will say, the one that I got through Amazon of the using R, it does, I didn't look at the format and font yet, but it does guarantee that all the page numbers are the same.
That's
For
good.
the Kindle version, so that's kind of nice. I
Well,
had to look though
okay.
at the, it's the Kindle version that you can.
Thank you for bringing up the Kindle version. So, with CRC books, there also are Kindle versions if you obviously buy it from Amazon. And I've been told by my publisher is that should be exactly the same as the text that's in a hard copy.
It's just like a picture of it.
Yeah.
essentially.
Yeah. Okay. Any other comments, questions? Okay. Excuse me. So there are other books that you may find useful too, especially depending upon your level of how comfortable you are with R. In particular, John Chambers' book is a very good book on using R. It is free. You can download it from the library, a PDF form. I think pretty much all newer Springer books are like that. Let's see, another Springer book was Gentle's book, and also Introducing Monte Carlo Methods with R. That is a good book as well. So also, in terms of the best bootstrap book out there, we'll spend about 4 or 5 weeks on the bootstrap in this course, is the Davison and Hinckley book. It is written at a level that requires you to have some experience with asymptotic statistics. Just be aware of that. But I think you can get around that and still get some good background of that. Now, unfortunately, they haven't come up with a new edition. This is still 1997 when it was written, but the few bootstrap books that have been written since then, they're not as good as this one. I really wish that they would update it. Also, there's a book by Matloff that's good on the art of R programming. And lastly, a book that I've requested from the library, but I haven't got it yet from the library through interlibrary loan, is Hadley Wickham's Advanced R book. I would anticipate that will be good. Wickham is one of the big people right now in R development, and so I would imagine that book is probably good too. So those are some options for you, in this course. So the prerequisites, Stat 883. You need to have a good background in Cassell-Berger statistical inference. Okay, I will expect that. Also, Stat 971. There will be some modeling issues that we talk about, and Stat 971 obviously is a big modeling class, so that's going to be helpful. In particular, what I hope we will do is take a look at some generalized linear mixed models, the actual computational aspects of, let's say, finding some of those integrals that pop up in generalized linear mixed models, and also the optimization that's needed for maximum likelihood estimation. And lastly, a good amount of programming experience with R. If you've taken one of my previous courses, you generally will have that, as long as you've been doing what I expect you to do, which is make sure you understand every single line of code in my courses. Sorry, should have brought some water with me. Now, there's a number of you who I have not had for a class before. This should not be an introduction to R. If you have very little experience with R, this is not the class for you. Okay? You need to be comfortable with R. We will do some stuff later today that will assess your level of comfortableness with R shortly. But this should not be an introduction to R for you. Now, I say that because I want to put you in a position for success. Okay, and if you don't have R experience prior to this course, or only a little bit, this is not a good course for you to be in. So great. So this gets into what I'm talking about that we'll kind of see as we go along what topics we're going to cover and stuff like that. And so that's why I came up with this grading system, which is a little bit different from past courses if you've had me before. So grades will be based upon simply as the total number of points possible out of the total, total number of points you've earned out of the total number of points possible. We'll get a percentage from that, and we will use then the standard grading scale there to assign letter grades. I do assign both plus and minus grades for students. Now the big thing that we will have this semester in terms of graded stuff will be graded assignments. So as you'll see shortly when we take a look at this, the tentative schedule that I've laid out, each topic will typically have at least one graded assignment. So there will be more graded assignments than, again, if you've had me before in a class when I have projects. Also, there's going to be some kind of combination of graded presentations or exams during the semester. Originally, when I was planning on, when I started planning for this course last October, I was going to have presentations being a large component. And the reason being is, especially for a PhD level course, which this is, giving students the opportunity to present some stuff that's not necessarily talked about in the course itself gives you good experience then later on for what you need for a dissertation. We have 11 students in here. Originally I was going to do day-long presentations for each student. That would be 11 days of the course taken up by student presentations. That's not going to work. So maybe it might be half-a-day presentations, or maybe group presentations, if we do presentations. I'm going to basically make an assessment about halfway through the semester and make a judgment if we want to do that. If we don't do presentations, then we will have a final exam. Right now, there will be for sure a midterm exam. There will be no exams before then, but there will be a midterm exam. It will be in this classroom, closed book. At least right now, I'm thinking it's going to be closed book, closed note. So prepare for the worst. And if it happens to be open book, open note, you can say yes. Prepare for the worst, closed book, closed note. But I will tell you for sure, you will be using the computers here. Okay, so it will be a computer-based test. Okay. Now these assignments that you will do, you know, I try to stay away from you giving me paper. You know, what you're going to be doing is giving me an electronic document. When you turn in your assignment, you'll be able to work in groups as well. And all these assignments, in terms of the text itself, needs to be in Word. The reason being is because I have a tablet PC here. It makes it a lot easier for me to grade using Word than if you had a paper copy or even a PDF copy. Please make sure, though, that stuff that you do turn in to me is completed in a professional manner, in terms of something that you would give your advisor, like a report, or let's say after you graduated and you're out in the workforce, a report that you may give your supervisor. It needs to be at that level of neatness. Otherwise, I will give it back to you and say, do it again. Again, we will be using R. The final exam class period, whether or not we actually have an actual final exam or not, we will be meeting Thursday, May 7th from 10 to 12, so please plan on being here. And lastly, I am required by the university to put some additional statements on my syllabus rather than printing it off on paper and killing a tree. I decided just to simply put this online as a syllabus supplement. I will show you shortly where you can obtain it. Okay, are there any questions about the syllabus?
Maybe you're going to talk about this later, but is this it for the class? Can we, so when we come in here, like we can assume that we can sit at our own computer?
Let's see. So we got 3, 6, 9, 10. So we got 10 in here right now. We have 11 registered.
Okay.
So yeah, you will have enough.
Okay. And can you remind us what the login information is for these?
Yeah. Let's see now. Have you tried just the Blackboard login?
Oh no, I haven't. I didn't know if
It
you
doesn't
wanted
work?
us to use. Yeah.
Okay, I believe you can try this. It did not work.
No.
s-statlab. I'll actually write it out. As a login. And then here is the login. Oh shoot. It's HH, capital H, and there's something in between. Yeah, I think it's just Harden. Is it Harden?
No,
No, is
STAT.
it
Stat?
HH stat?
I think it's HH and I'm very happy.
Yes. Harden, Hall, Stat, I'm very happy.
Yeah.
I think that's what it is. So let me, no spaces in there. So try that. Does it work?
It's saying welcome,
It's,
so.
it's
Good.
thinking about working.
Yeah, you know, often it takes a while to log on to these computers. I don't know why.
Yeah,
Thank you.
it worked.
Two exclamation marks, so
Yeah.
we're very happy.
Really happy about being in Hartman.
Yes. Other questions? Okay. Let's see here. What's next? Let's briefly talk about my website, just so that you know the information that's out there and what will be out there eventually. So this is just the main web page there. Let's take a look at the schedule web page. This will also give us an idea of what we're going to be talking about this semester. Some of you, who asked me more information about the class last fall, you've kind of seen some of this already. So some of this won't be new. So this is a tentative schedule of what we're going to be talking about. So today, introduction, syllabus, website. We're going to do an R background check. We'll have something called a day number 1 quiz as well that we will talk about later. And then you see something called video. I record all my classes. So this camera that's pointed right at me is recording me right now. And after class, what I will do is do some post-processing of this recording and then eventually upload it to my course website. Okay, I'll put a link where you see video. Please be patient. It should be up by the end of the day. But there might be times where I might not be able to put it up there until the following morning. But typically, it will be done within a few hours after our class. Excuse me. Now, the purpose of having these videos there is, first of all, if you wanted to, let's say, review some content of what we discussed in class, maybe it wasn't clear, you have the video available to you to make that, to do that review. Also, there may be times where, due to extenuating circumstances, you're unable to attend class. Well, there's your backup. You can watch the video. Please don't take advantage of the fact that these videos are out there by deciding that you're not going to come to class at all. So I don't have to put those videos out there. And if I start seeing that students are deciding not to come to class, I won't put the videos out there. So then next time, what we will start talking about is Monte Carlo simulation. All of you have done Monte Carlo simulation before, at least a little bit. But what I'm going to do is discuss in the context of, well, first of all, why does it work? So there will be some math involved. But also we'll discuss in the context of what would you want to do for a statistical research paper. This is a PhD level course. So we are thinking about PhD topics in terms of those that are for statistical research. I'm not concerned about you being able to do an analysis for a subject matter researcher. That's not the purpose of this course. The purpose here is to set you up to do statistical research. Okay? So that's the mindset for the topics that we're going to talk about and how we talk about them. We'll discuss techniques that you can use to, for example, let's say if you propose a new statistic for some research. Well, how can you determine if this statistic is good? Well, one way is through Monte Carlo simulation. There are specific techniques that you will see throughout the statistical literature that people use. We will talk about those techniques. So we'll do MC simulation, then we'll get into the bootstrap. I anticipate that this will be the minimum number of days that we will talk about the bootstrap. Again, as you know, I taught Stat 950, which is bootstrap methods and their application for this department. In fact, I'm the one who developed it in 2006 as a response to our previous academic review, program review that we had, who said that hey, we're not talking about the bootstrap or other computational statistics tools, and so that's why I developed that course. It's a great course, but typically now what you see most department statistics doing is that they'll have a big section of a computational statistics course be about the bootstrap. And so I have to figure out, and I haven't quite written up all those lecture notes yet for our class, I have to figure out how to take my 15 weeks of bootstrap material, condense it down into, was about 7 class periods. So I have to decide, well, what stuff am I going to throw out? How much detail I'm going to get into some stuff? And that's what I'm going to be starting to do probably later today. It's going to be a fun challenge. So with respect to the bootstrap, we'll talk about the basics of it, how to do it in a computational standpoint, but also why it works. And so we'll get into some of the math behind it as well. And then we'll talk about confidence intervals, hypothesis tests with respect to the bootstrap, and also linear models with respect to the bootstrap. Okay. Now, one of the big things that has again changed since, let's say, when I started grad school, is with respect to computing power, being able to use parallel processing. While people were doing parallel processing then, it's just a lot easier nowadays to do it, and also you can do so much more with it. If you don't know what parallel processing is, basically you can think of it this way in a very general sense. Let's say that you want to do a simple Monte Carlo simulation. Well, you could just set it up on your computer and let it go and run. Alternatively, what you could do is maybe you have access to, let's say, these 4 computers here. Put some of the simulation on this computer, this computer, this computer, and this computer, and then in the end, combine them. So instead, you combine the results you get from the 4 computers. So you're doing the processing of the Monte Carlo simulation in parallel, and then you put it together. It's parallel processing in a very simple sense. So we'll talk about parallel processing. We'll focus on especially doing it with respect to Monte Carlo simulation and the bootstrap. That's why I put it in that place in the semester. Then next we'll talk about HPC. Does anyone know what HPC stands for? High performance computing, yeah. What we're going to be doing is using the supercomputers that we have available to us on this campus. They're actually up at UNO, but we have access to them here. And so we got some really good supercomputers available to us. And these supercomputers basically allow us to take parallel processing to the next step. Here you can have, let's say, thousands of computers essentially that you have access to. And so just imagine how fast you can maybe do stuff if you have thousands of computers rather than just one simple computer. So with the HPC, we will have to, all high performance computing, the actual operating systems that you're using for that, in terms of computer operating systems, is Linux. And I would expect that probably most of you do not have any kind of Linux background. And so we will have an introduction to Linux. Enough so that you can get on the computers and you know how to use them. Next, we'll talk about numerical differentiation. Why do you think we need to talk about numerical differentiation? Why can't we just take derivatives by hand? Well, you know, just sometimes it's difficult to do that. And other times you want maybe automated ways to take the derivatives so you don't have to program them in by hand. You know, all of you have calculated, for example, a Fisher information matrix before. And, you know, depending upon the number of parameters you have, you know, that Fisher information matrix can be kind of big. Depending upon the actual, let's say, model for your response, you know that can be kind of big. Maybe instead what we can do is tell R, take the derivative for us. So we'll look at the math behind how that works, and then we'll look at how you can implement an R. Next, we'll talk about optimization. Why do you think optimization is important in statistics? Where's the number 1 place that we use optimization? Thinking of 3 letters. Maximum likelihood estimation, yeah, so MLE. That's an optimization problem. There's other optimization problems in statistics, but that's the big one. And so we'll talk about, again, some of the math, and then we'll get into how we can actually do the stuff in R. Numerical integration. Where's a place you've seen numerical integration in your schooling so far? Well, Bayesian, that's a big place. I'm thinking more like a Gauss quadrature, if you've heard of that. You should have. Where did you learn about that? Stat 971. Okay. Well, we'll look at how it's done mathematically, and then we'll also look at how we can implement it in R, which you probably didn't see in Stat 971. If there's anything wrong with using stats. But we'll look at, I have a nice little example already written up of fitting a generalized linear mixed model using R without using, let's say, canned, like a glim-mix kind of function, where you actually have to do the numerical integration yourself. You know, why? Well, especially when you're doing research, you're not going to be using functions probably that other people have already written, because after all, it's your research. You're going to be the one who's actually writing the function to fit a model or do something. And so you need to know how to do the stuff yourself without relying on proc lim-mix, for example. And then we have a whole bunch of TBAs to be announced. For those of you who see my previous schedule that I came up with last fall, you know that there's some topics out there that I have ideas about. I decided not to put them there yet until I know for sure, yes, we want to talk about them. Topics that I'm going to choose from for those other, for I guess all of April, include Markov chain Monte Carlo, MCMC. So we will look at, for example, a Gibbs sampler, Metropolis-Hastings algorithm, how it works. The EM algorithm, probably most likely take a look at that. EM stands for expectation maximization. Anybody actually use EM algorithm in your classes yet? Okay. A very, very useful tool to do maximum likelihood estimation when simple ways that you learn about in Stat 883 don't work. I do highly recommend to you, now that I think of this, remember to tell you this, some of these topics that we're going to be talking about, they're actually introduced in Cassell and Berger. You probably didn't actually ever get to them, but they're actually introduced there. Very short segments. So just the other day I was looking up some stuff in Cassell and Berger, and I noticed, oh, there's like half page on Metropolis-Hastings algorithm. Well, that's cool. So, you know, you should always think about, even though I didn't put it as a suggested reading, think about always going back to your Cassell and Berger book and see what they say about a particular topic we're talking about in more detail. So EM algorithm, let's see if I actually wrote down the ideas. Let's see now. How to construct an R package. It's very common nowadays that for students who are writing their dissertation, they also write a corresponding package with it so that people can implement the stuff that they're doing their stuff on. So, but how can you write a package? Well, probably spend maybe a day or two on it if we do that. Something I'm interested in learning about, and I actually just attended a workshop about it on Friday, is Python. Anybody heard of Python before? Yeah. So Python is, you could say, the R equivalent for computer scientists to do statistics. That's a very rough explanation, but just think of it as another computing language. I didn't really know anything about Python until Friday when I took a workshop on it. And you know, one thing that I like to do, especially when I'm teaching, is introduce new topics so that not only do students benefit, but also I benefit, because I have to teach myself that stuff first. So ideally right now, I'd like to spend 2 days on Python. We'll see. So anyway, so that will give you an idea, and especially if we do presentations at the end, that will take up some of the TBAs as well. We'll see. Any questions about the schedule and the topics that we're going to be talking about? Okay. So then we go to grading materials. This will just be where I put assignments. I put answer keys there. You see that day number 1 quiz that we'll talk about as well. We have a listserv associated with our course. This gives us a way for all of us to communicate as one group. So as you can see here, if I go to, this should be week 1, January 2015, you see basically an archive of all the stuff that's been posted there already. So you've gotten a head start on day number 1 quiz, and so that's why you see that stuff there. And if we go to my welcome here, you see an explanation of what this listserv is, or the purpose of it. Simply, if you have questions on assignments or other things relevant to the course, post your question here rather than emailing me about it. Okay? So if you, for example, on assignment number 1, let's say you have a question about, how do you do part 1A? Don't email it to me. Post that question to the listserv. Because if you have that question, probably somebody else in the class also has that question. And that way, when I respond, or perhaps another student responds, you can all learn as an entire group. Okay? If, though, you have a question about, question about your grade, or you want to tell me that you're going to be absent from class, or similar items like that, that's really personal to you, email that to me. Probably other students in the class don't want to know that. Just want to make that clear. So once I was teaching my bootstrap course a number of years ago, I actually had a student who was having particular, I'll just say his stomach was unsettled. It was causing certain reactions, and that was why he couldn't come to class. He decided to post it to the listserv to let everyone know about that. It gave everyone a good laugh. Anyway, so if you're not sure what to do, post it to the listserv or email me. Just simply ask yourself the question: will other students benefit from seeing the message? If the answer is yes, post it to the listserv. Okay. So how can you post stuff to the listserv? It's actually fairly simple. Oops, why am I not going backwards? I don't know. Just come back here. Email this address: compstat@listserv.uno.edu. That's it. But before you do that, you need to do one extra step, and that is you need to what's called subscribe to the listserv. And if we come over here on the right-hand side, you see a link here called subscribe. What you'll need to do is get to my website, get to the listserv, click on subscribe. Let me make this a little bit smaller. I don't think it needs to be like that. And you can put in your name, your email address, leave all the defaults here as they are. That will be fine. And you'll see a button here called subscribe. Click on it. Now you're subscribed. So what that means is that you can actually email the listserv with questions. Also, it means anything that is actually posted there from other students, you'll get a copy of that email back. Okay? Now, there's another way that you can actually post a message to the listserv. Over here you have something called post new message. You can type your message here as you might expect and then click on send. In order to do that, in order to have this web site interface to be able to post stuff to the message board, you will need to do another step, and that is explained on my topic materials webpage in this listserv help document. Okay. So with this listserv, I think I've already said this, but just in case I didn't, what we have here is an archive of all past posts sent to it, and so it gives a nice, essentially a message board feel to the listserv as well. Any questions about the listserv? Yes?
What's the difference between discussion board and this?
Well, a discussion board will not necessarily have the an email sent to you that has the posts. So a listserv does have the email. By having the archive function, it simply serves the purpose of the discussion board with that email. Now, yes, some discussion boards will have that email too, but if you want to know the specifics behind the difference between like a message board, discussion board versus a listserv, that email part is the difference.
Is it free to use by any instructor or is restricted to buy or purchase?
Any instructor can create these. I would assume students can create them as well. I believe it doesn't the student
Yes.
that student organization.
Ours is hidden though. I don't know how that happens.
I think that's the
You
default.
You can't search it. You can subscribe to it.
Just as a side note, you should let faculty do that too, because I'd be interested in that.
Okay.
We can talk about that another time. But anyway, you can change that aspect so it is public if you don't want to. Okay, so the topic materials webpage then is where I will post our lecture notes, our programs, data sets that we might be looking at. I will post it there. For every other class period except for today, you will need to go there and download my lecture notes and either bring them with you electronically on a computer or print them off and bring the paper copy lecture notes with you so that you can simply take notes on it. So all my lecture notes that I will present in class, and sorry, this probably wasn't clear, all my lecture notes will be in Word documents, and we will simply go through the Word documents in our class, where I will add certain things to it as we go along, and you probably will want to take notes on that kind of that stuff. Okay, so again, next time we will talk about Monte Carlo simulations, so it will be good for you to have those lecture notes with you in electronic or paper format. And everything then is laid out corresponding to similar to what you saw on the schedule webpage. Okay. Let me make sure I'm talking about everything that I need to. Let's talk about the day number 1 quiz. So this is one of the 2 times where I will use Blackboard during the semester. So after class, you can go to Blackboard. I should get logged in already. There we go. After class, you can log into Blackboard, go to the actual course website for this course. So here we go. And over here on the left side, you see something called day number 1 quiz. And all this as you have to do in Blackboard, you have to click a whole bunch of different times to get to where you want to. So eventually I have to click day number 1 quiz again. And then I have to click on continue again. And then finally, yes, we get to the day number 1 quiz. Okay, what this just simply is, often the first day of any course that you take, the instructor will ask you to provide some information about yourself. Let's say like where you're from, what's your experience in this topic before taking this course and so on. And that's all the purpose of this is. If you complete it, you get 5 points. If you don't complete it, you get 0 points. And so this will then be part of the overall point structure for our course. So just real briefly, question 1, give me your name. Question 2, give me your email address. Tough questions. 3, major. Tell me the degree you're pursuing. Please list out all the STAT courses that you've taken. Tell me what your highest math class is. This will be helpful to me. Describe your experience with R. I do want to know that. Okay. Tell me where you're from. And then lastly, outside of Blackboard, log into the listserv. Or log on to the listserv and subscribe to the list. Similar to what I just showed you. And then actually submit a message to make sure that you can use it. Once you're done with that, type I'm done there. And then you come over here, click on Save and Submit. Don't click on Save All Answers. Click on Save and Submit. And that will tell me you have completed the quiz. Please complete this by class time on Thursday. Okay, so that's the day number 1 quiz. Are there any questions? Okay. If there's no questions, then let's actually do our background check. So at least in my Bootstrap course, where I teach that, I like to do kind of a intro to R in a more advanced manner than what you would see in my 800 level courses. And that's kind of the purpose of this. But I decided to change things to make it a little bit more interactive. So let's first of all talk about the format of my lecture notes. This is the format that I will use for all my lecture notes. In terms of Again, it's a Word file. You'll notice that I use a size 20 font everywhere. For computer code, I'll use a smaller font. But I'll use a size 20 font for regular text. And the reason why I do that is to make sure that no matter what room I go into, people are going to be able to see what's projected up. So that's why I use such a large font. Since I use such a large font, you probably don't want to print off these lecture notes as one page per sheet of paper. If you notice here, I actually did 2 pages per sheet of paper. This was actually on accident. Normally I do 4 pages per sheet of paper. It's up to you. I recommend 2 or 4. I prefer 4, but it's up to you what you want to do. Also, when you download my notes and you open it up in Word, typically you come up to a page that looks like this, where if you notice over here on the right-hand side here, you have comments. In my lecture notes, I like to put comments that essentially is hidden text. So you can see my comment corresponds to that pink area up there. Essentially, it's hidden text in Word. And basically, these comments are for my purpose, not necessarily for you. You're welcome to look at them, but they're for my purpose. Just help me remind me of something, maybe remind me of how to explain something when I do the lecture. Again, you're welcome to take a look at them. But the one reason why I want to point this out is that the default way that Word opens up is like this, so that you actually see the comments there. And if you were to print the document, you will get the comments printed too. And that, especially if you're trying to do, let's say, 2 pages per sheet of paper, or 4, definitely for 4 pages per sheet of paper, that could be distracting. It makes everything else really, really small. So what I recommend is before you actually print off my lecture notes, turn off the comments. And the way that you can simply do that, if you don't know already, go up to Review. There's actually a few different ones. Show Markup. Come over here to, instead of Show Revisions in Balloon, Show All Revisions in Line. And then they go, and when you print it, it will look a lot nicer. So I came up with this style of using comments in Word back when the default for Word was not to show the comments immediately when you open up a new Word document for the first time. Now Microsoft changed that to the default as you do see the comments, which screws up my teaching style. Anyway, let's see. Okay, so I think we're ready to go. Let me turn off my spell checker here. I'm going to minimize that. Okay. So the purpose of this section is simply to evaluate, do you have the right background to have success in this course? If a significant portion of what I'm going to be talking about here is new to you, you should come talk to me after class or after our next class as well. So to tell me about your background and to help me evaluate, do you have a sufficient background to take this course? Also, the purpose is to provide simply a reminder of important art topics that we can maybe refer back to as needed during the semester. So first of all, we do have, I guess, 2 what I would consider fun questions. What is S? Can someone tell me what S is, other than a letter of our alphabet that's before R?
It's a statistical package before R.
It's not necessarily a statistical package. It's actually a statistical language, similar to like C or Fortran. It was an actual language that was developed, and I can, oops, maybe I don't hide that. It was actually a language that was developed in the mid-1970s at AT&T Bell Labs. John Chambers, hopefully that name sounds familiar, that he's the author of one of the suggested readings for this course, suggested book readings. He was the primary developer on it. And it was the reason why S was chosen, the letter S, because statistics. simply. And there's a nice YouTube video that came out within, I think, the last year. And here is John Chambers on the left. He is being interviewed by, I don't remember his name, but he is a famous statistician. I think it's Hastie, Hastie. Let's actually find out.
So who's John Chambers?
He's the one on the left.
Left of mine or yours?
Okay, he doesn't say whose name is, but I believe it's Hastie. He is a famous statistician. And anyway, so it's a nice 10-minute video about how S came about and how it eventually evolved into R. If you like this stuff, I recommend taking a look at it because it's nice to know about the history of how this stuff came about. So S came about in the mid-1970s. Can someone tell me what S plus is? Anybody heard of S plus? Okay. What is S plus? Anybody use S plus? It's actually used to be at least free for students. Okay. S plus came about in the 1980s when a company bought the exclusive rights to the S language. So no one else could use the S language. Only that company that did the S plus could use it. And then they sold the S plus software, similar to how SAS was sold. The reason why it's called plus is because they added stuff to it. And eventually, S plus, starting about the late 1980s, up until when I was throughout the 1990s when I was in grad school, this was the #2 statistical software package for statisticians, and where its main use was actually by those who did statistical research. We'll get back to that in a second. Another little fun question here. I mean, if you don't know, I guess these two questions, that's okay. What is the birth date of R? When was version 1.0.0 released? Does anyone know?
95.
Nope. Higher. We'll play the Price is Right game.
97.
Higher.
99.
Higher. 2000.
Uh-huh.
But the actual date? February 29th. So, of course, and that is always a joke, that how old is R really? Well, it's like 3 years old. Anyway, so that's when it was actually released. It was actually the first introduction of R to the world really came about in a 1996 issue of the Journal of Computational and Graphical Statistics. I was actually a subscriber to that journal as a student. And I actually have a paper copy of this article, but surprisingly, I didn't pay much attention to it. Maybe I had better things to do in terms of like my linear models homework. But it wasn't until fall of 2000 that I first heard of it. And what actually concerned me was this was my first semester at Oklahoma State University, and one of the first things I did when I was there was I had the university buy a site license for S+. So they spent thousands of dollars, not as much as you would for SAS, but thousands of dollars to buy this site license for S+. And then in I think it was December of 2000, I heard about this thing called R. And people were saying, oh, this is like a free version of S+. I was like, oh no, there goes tenure. Anyway, but the way that R was talked about then was not unlike S, because remember the people who made S+ had they had an exclusive license to the S language itself, and as SAS actually found out recently, you cannot what's the right word? Patent code itself. I mean, you can make it like proprietary and not let people use it, but people can use the same syntax and develop their own language. And that's essentially what R did. So all those people, all those stat researchers that were using S+ before, now migrated to R because it was completely free. Back up about that SAS thing that I just mentioned. So SAS lost a lawsuit a couple of years ago to a company based in the UK, where basically for like base SAS and maybe some other stuff, they've actually developed their own version of it using the same syntax. SAS, of course, as you might expect, was upset, but they lost the court case. So you can't patent that kind of stuff. Okay, so now we're getting into some stuff that I am serious about that you do need to make sure that you understand. Because someone give me a definition of what an object is in R.
It's I don't know if this is the right word, an entity that stores information.
Exactly. So there's an entity in R that can store information. It can store numbers, can store characters. That's what an object is. How do you get something into an object? You make what's called an assignment. How do you make an assignment? There's two ways.
Equal sign or the arrow, like arrow.
Yeah, the equal sign or the thing that kind of looks like a left arrow. The left arrow has always been around in R and S+. The equal sign came about 9-10 years ago. Still predominantly the core R, I shouldn't say the word core, but the main R users use the less than dash, even though it's one extra keystroke. Okay? I've only seen one person who's a big R user who uses the equal sign. You could actually, in the past, you could actually use an underscore. And in fact, when I was doing S+ in grad school, that's what I used. And then underscores went away and you can no longer use it. So, for example, it's too obvious. You can make that as an assignment. So X is an object. Could someone tell me what a function is in R? I know these are kind of general things, but you often don't think of definitions of what they are.
Collection of different commands that you can execute all at one time.
Exactly, a collection of different commands that you can execute all at one time, and you can execute it whenever you want to. Let's say within inside of a program. So it's different from a program, where a program could be a collection of functions or a collection of non-function code. But this function, is kind of like a proc in SAS, but it, in like a C or Fortran context, it's a function or a procedure and stuff like that. Now, some notes. A function is an object too. In fact, even though you don't think about this, the plus sign in R is a function. The multiply sign is a function. All that stuff is functions. So that's kind of interesting. So here's a big question that is part of the R background check. Could someone tell me what the syntax is for writing a function?
Function name.
Well, I want to first make an assignment. So let's say I call my function, let me get my red pen out here. I want to make it thin. So I want to create a function called, let's not call it X. That's a poor choice. Let's call it, every time I use this as a function name, I think of let's get funky. I have a function called my.func. So if I want to create a function called my.func, what should I do next? The assignment. Then what?
Function.
They're not called parameters. What are they called? Arguments.
Yeah.
So a list of arguments. So maybe I might have an argument called X. How do I separate arguments? Comma. Maybe I have two arguments called X and Y. I separate them by commas. If I want to assign a default value for an argument, what would I need to do? Suppose I want X by default to be 5. Colon. Not colon. So maybe equal 5. So if you squeeze that in there, that will be a default. So what should I do now after I've done function xy? the left curly bracket. Then what goes here? Just your code. So I'll just put a box here, code. Let's, why don't we actually put something there? Let's say I want to simply do x plus y. I can make an assignment. We'll call it z. Let's say I want to return this result, this thing in z, back to the user when they use this function. What should I do next? Put z here, and then what? Close the bracket. Excuse me? We'll talk about that shortly. Okay? So now I've written my function. If I want to run this function, what should I do?
Print.
I don't need print. My.func.
The values. Oh, X is already given.
Suppose I want to do 1 plus 1. And that will allow me to run it. Now, I strongly recommend that you get into the habit. I know it's easy not to, especially when you can often develop bad habits in any kind of programming language, including R. Always try to get in the habit of using the argument names with their actual values. Because you could also run this how? Yeah, just with 1 and 1. Well, let's say if I had 2 here. How does R know that x or y is equal to 1 or 2? Well, it does it by the order. Okay? And you can get in a bad situation if you accidentally don't know the order or you get the order wrong. So always try to use the argument names. Okay. Excuse me. So we've already done y is, what is the syntax? Y is the last line of the function. So important, we did that already. Now there was a question about, well, in addition to just simply putting z there, this last line is just so important because that's what's returned to the user. In addition to using putting the word putting z there, you could also say return parentheses z and parentheses. That's actually not needed. That's an example of old-time S+ code, actually. Okay, so you don't need to use the word return. Let's say you don't want, this is a tough question, which you may not get, even if you've taken one of my classes, even though it was in one of my classes. Let's say you don't want anything returned. What could you do? Because the last line is always returned, unless you do something. If you take my categorical class, it's chapter 5. I wrote a big function for diagnostics for a generalized linear model. I think I use it there. There's a function called invisible. That's useful, let's say if you're creating a function that maybe you're just using for plotting. You don't want actually anything to come back to the user. You can say invisible parentheses z and parentheses, and so that you don't get a bunch of stuff coming back. Now, oftentimes, you will have more than one thing that you want actually returned with a function. Maybe you want, even though it doesn't necessarily make sense here, x, y, and z returned in that last line. What would be potential functions that you could use to try to organize the items that you want returned? You use a list, you use a data frame. What else? How about the simplest one? C. You use a C vector. You use matrix. So if I did C parentheses and parentheses there, what I'm simply going to get is a vector. If I use list there, I could do that. Just a second. If I ran then this, let's say I did save. Can't write. Save gets the results from my.func, and if I had a list up there, how would I then access information that is in save? Save, you can use square brackets, but how it does. $, X, for example.
It depends on how you save. It depends on how you save it. If you use the list with like plus you use the save bracket. Let's talk about it.
I think you're talking about this.
Yes, for the list.
Yeah, you could do that too. But you know, if you already have a name, if I have a name stuff there,
Oh,
that's the way to. That's often easier. So you know, you could do a data frame as well, and of course, what's the relationship between a data frame and a list? The data frame is a special case of a list where all the elements in that data frame, or all the elements in that list, are exactly the same length. So think of it as, you know, you got a data set, you know, your first column of data is going to be the same length as the second column, and so on. So it's very convenient then to have a list then as a way that you're organizing everything together, but everything just has to have exactly the same length. Okay, let's see. We're done. Yes, sorry.
I don't mean to cut you off because I think that clock's behind a little bit.
Oh,
Yeah.
thank you. Okay, it is 12:17. You got 2 extra minutes today. Thank you. Are there any questions? Okay, since we obviously didn't get through all this today, we'll pick up on it on Thursday. It won't take very long, and then we'll start the Monte Carlo simulation notes. Please make sure you got data room and quiz to me by class time on Thursday, and bring the notes for the Monte Carlo simulation with you. Okay, that's it for today.